Hello, welcome to my channel. In this video, we will go through the example 7.2 of chapter 7 Electrodynamics Introduction to Electrodynamics by David G. Griffiths. Okay. Before starting the video, I will request you to subscribe the channel and press the bell icon so you won't miss any of the upcoming videos. Okay. And the link of the playlist is given in the description, in which all the problems of chapter number 7 are solved in a sequence wise. Okay. Now we have example 7.2 here. In this example, it says that we have two metal coaxial cylinder, one of radius A, which is inner cylinder, and the other is of radius B, which is outer cylinder. Okay, and they are separated by a material of conductivity sigma. Okay, and now if they are maintained at a potential difference of V, okay, then what current flows from one to another in this length L? Okay, so the required thing here is to find the current. Okay, and now we will go to the solution. As we know that current is equal to integral of J dot dA. Okay, but as we know that J equals to sigma and E. Okay, and electric field between the two cylinders is given by uh, Gauss's law. Okay, which is lambda divided by 2 pi epsilon naught into S in the direction of S, where S is the radius. Okay, so when we put this electric field in J, it gives sigma into lambda divided by 2 pi epsilon naught S in the direction of S. Now let's say this is equation 3. Okay, and this is 1. So we will put 3 and 1. Okay, let's name it equation 2. So we will get I equals to, where the constant will come outside of the integral, so sigma into lambda divided by 2 pi epsilon naught. Okay, and S, and integral will only apply on dA, which is the surface area of a cylinder, where the surface area of a cylinder is I equals to lambda divided by 2 pi epsilon naught S, where this integral of d is equal to 2 pi S into L. Okay, now 2 pi and S will cancel out. We only left with where I is equal to sigma into lambda divided by epsilon naught into L. Okay, now we have found the current. Let me write the equation again. I equals to sigma into lambda divided by epsilon naught into L. Here we know everything, but the charge density is unknown, so we will calculate this. Okay, now we will use potential difference, okay, to calculate this lambda, and we know that the potential difference is equal to minus B to A and E dot dl. Here electric field was given by equation 2, which was lambda divided by 2 pi epsilon naught into S in the direction of S, and dl was given by ds in the direction of S. Okay, now put these two in this equation 4, so we will get V equals to minus from B to A, and E is equal to lambda divided by 2 pi epsilon naught S, and this will be dotted with ds, and where S and S dot S gives 1. Okay, now this is a general multiplication. So V equals to, where we will bring the constant outside of the integral, so lambda divided by 2 pi epsilon naught. Okay, and we will integrate from B to A 1 divided by S into ds. Okay, now this integral is equal to, we will solve it here, V equals to minus lambda divided by 2 pi epsilon naught, and this integral is ln of S and from B to A. Okay, we get minus lambda divided by 2 pi epsilon naught. By putting the limits, we get ln of A minus ln of B. Okay, when the negative side is multiplied, when the negative sign is multiplied inside, we will get V is equal to lambda divided by 2 pi epsilon naught, and this will ln of B minus ln of A, and it will give lambda divided by 2 pi epsilon naught and ln of B divided by A. Okay, so we get the potential is lambda divided by 2 pi epsilon naught, okay, and ln of B divided by A. Now we will find lambda here, so we will multiply the other quantities here. Okay, so lambda equals to 2 pi epsilon naught into v, and this will divided on both sides, so we will get ln of b divided by a. Now this is the linear charge density on the inner cylinder. Name it is equation 6. Now we will put this equation back into the equation of current, which was equation, we didn't name it, but the equation was uh, I equals to sigma divided by epsilon naught and to lambda L. Okay, name it is equation 7. So put equation 6 in 7, we get I equals to 2 pi epsilon naught v divided by ln of b divided by a and sigma divided by epsilon naught into L. Now this epsilon naught will cancel out, and E equals to 2 pi sigma L divided by ln of b divided by a, and this will come V. So from here we know that the current flows from one cylinder to other is equal to this equation, okay, which is equation 8. This was the solution, and from here we can also guess that the resistance of the material is ln of b divided by a divided by 2 pi sigma and to L.